Hello everyone, I'm Frank and welcome to Frank Puzzles. And this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum. And there's a lot of really smart people there. Today's puzzle is called Solid Whispers by Lizzie1. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. We also have Renban lines, where the purple Renban lines form a set of consecutive non-repeating digits. So, for example, these for 7 digits must form a set of 7 consecutive non-repeating digits. So it could be from 1 through 7, 2 through 8, or 3 through 9 is possible. You could not have something like the 1, 3, 4, 5, 6, 7, 8, because 1 is not consecutive with 1 doesn't form a consecutive set with 3 through 8. And that's an example of how Renban lines work. We also have what I call Whisper 5 lines. Other people will call that German Whisper lines, but I call it Whisper 5 lines because the setter came up with that naming, and I thought that made a lot of sense because it is very easily extensible. But on a Whisper 5 line, adjacent digits must differ by at least adjacent digits on the green lines must differ by at least 5 on these lines. So, for example, if this were, say, a 3, this would have to be 8 or 9, because the only digits which are 5 or more away from 3 are 8 and 9. And that's an example of how a Whisper 5 line works. And finally, we have region sum lines, where these blue region sum lines, box borders divide any blue region sum line into segments, and each segment on a region sum line must sum to the same sum. So, for example, these 3 digits must equal the same sum as these 3 digits. These 2 digits must equal to the same sum as this digit, which must equal to the same sum as these 2 digits, etc., etc. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so first one here. We have a region sum line where these 5 digits must equal these 2 digits. 2 digits adding up to 2 digits must add up to can only add up to 17 at most. 5 digits, on the other hand, can have to add up to 15 at least, because it's 1, 2, 3, 4, 5. So therefore, this sum must be between 15 or 7 to 17. Well, how do you add up to 17 with 5 digits, or up to 17? You could go 1, 2, 3, 4, and 7. So one thing you know in this box is you cannot have a 1 through 7 at all. Sorry, you can't have any digit that's greater than 7 on this region sum line here, which means the 9 in the box must be on the Renban line, and so must the 8. So we have a guaranteed 9 and 8 here on the Renban line. This is a 7-length Renban line with a 9 guaranteed, so it has to have 3 through 9 then on this Renban line. So this Renban line is 3 through 9. And the 8 and the 9 have to be in box 9. So this cannot be 8 or 9. This can't be 8 or 9 for the same reasoning. These 2 digits must add up to 15 at least. So it's at least 6 and 9. And we have 1, 2 definitely on this region sum line here. Let's see. What else do we have? We have on here in box 7, we have a Renban which is 5 in length. It must have a 5. And we have 2 each. On a Whisper 5 line, you'll always alternate between low digits and high digits. If you want to see why, you can look at one of my videos with Whisper 5 lines in Learn How to Sudoku. But basically, because of that, you alternate between low and high digits on this Whisper 5 line, which means you have to have 2 high digits, which are 6 through 9, and 2 low digits here, which are 1 through 4. Well, if you have 2 high and 2 low digits here, the rest of this red band has to have a 5 and 2 highs and 2 lows. The only red band which satisfies that is 3 through 7. So this must be 3 through 7 here, and the remaining digits have to be 1, 2, 8, and 9. Well, where are 1 and 2 in row 7? They can't be here because they must not be. The red band has to have 2 highs and 2 lows, and it has to be consecutive, and it has to have a 5. So therefore, it must be 3 through 7. 1 and 2 can't be here. 1 and 2 can't be here because this red band's 3 through 9. So that means 1 and 2 have to be in box 8. And again, you always alternate between low and high digits. So 1 and 2 are both low, so this must be 1, 2, 1, 2, and this is a high digit, which could be 7, 8, or 9 here. Since this is low, this must be high here, so that's 8, 9, which means this is low, 1, 2, which means this is high, 8, 9, which means this is low, 1, 2. And this digit must be high then, which is 6 through 9. We have a 6, 7, 8, 9 quadruplet in box 8, which eliminates 6, 7, 8, 9 in the rest of the box. So this must be 3, 4, and 5. Well, this has to be consecutive. So it's either 3, 4 or 4, 5 here, which makes this 3 or 5 here. This also eliminates 3, 4, and 5 in the rest of the row. So no 3, 4, 5, no 3, 4, 5. Okay. We have a 6, 7, 8, 9 quadruplets in row 9 also, which eliminates 6, 7, 8, 9 in the rest of the row. So this is 3, 4, 5, and this is 1 through 5 here. This can't be 3, 4, 5, so it's 1, 2, 6, 7 as possibilities. Because we know this is 1, 2, 6, 7, now we know we have to have a 6 or 7 on this region sum line, which means it cannot be 1, 2, 3, 4, 5 adding up to 15. So this can't add up to 15. It's at least 16, so 6 is not available. And now we have a 7, 8, 9 triplet in this box, which eliminates 7, 8, 9 in the rest of the box. So this can't be 7, 8, or 9. It's 6, which only can be next to 1 on the Whisper 5 line, which forces this to be 2. 2 eliminates 2 in the rest of the row. 1 eliminates 1 in the rest of the row. So this is 6 here. And this has to be at least 16. So this has to be at least 9 here, which means this cannot be 9 here. Where is the 9 in row 7? It has to be one of these 3 digits, which eliminates 9 there. So where is the 9 in row 8? It can only be here now. So this is 9. This is one of these is 6 or 7, and again, it cannot have an 8 here because you only have 1, 2, 3, 4, 7 at most as the highest digit. So this is 1, 6, 7 as a triplet, which forces this to be 8. That eliminates 8 in the rest of the box. And where is 8 then? In row 7. Can't be here because this is 9. This forces this to be 8. This can't be 8 here. It's 7, 9 as a pair. That forces this to be 8 here. Well, 7 and 9 add up to 16. And 5 unique digits trying to add up to 16, you can only have 1, 2, 3, 4, and 6. So this cannot be 5. Cannot be 5. So you have 1, 2, 3, 4, and 6. So this is a 1, 6 pair. This is 2, 3, 4. That eliminates 2, 3, 4 in the rest of the row. So this can't be 3, 4. It's 5. No 6 here. It's 7. So no 5 or 7 here. This is 3, 4, and 6. That eliminates 3, 4, and 6 in the rest of the row. So this is 5, 7, 9, which eliminates 5, 7, 9 on the rest of this Ren band. So this can't be 5. It's 3. This can't be 3 here. It's 4, 5 as a pair. 5, 7, 9 eliminate 5, 7 here, and it eliminates 3 here. So this is 4 and 6 as a pair. Okay. Um, so let's mark these as low and high. I don't know if we need to really, but I like coloring, so let's do that. Low, these are high, these are low, this is high, this is high, this is a low-high pair. Okay. Where next? Remaining, okay, so this digit is equal to the sum of these two digits. So far we could have 3 here with 1 and 2. That is possible. This 4 eliminates 4 in the rest of the column. So we cannot have 3 here because that would force us to be 1, 2, and that would eliminate all possibilities for that cell. No 4, obviously, because of the 4, 6 pair in the column. 5 cannot be 1, 4, cannot be 2, 3, because that would eliminate all possibilities for that. No 6, obviously, no 8, obviously, so it's a 7 or 9. If we have 7 here, we can't have 1, 6 or 3, 4 here. It must be 2, 5 as a pair. If we have 9 here, what would that make? We could not have 1, 8. No 3, 6, no 4, 5, so it would have to be 2 and 7. So we're guaranteed a 2 here, which eliminates 2 in the rest of the column, so this can't be 2, it's 3. That eliminates 3 in the rest of the box. That's 3 in the corner. We celebrate, because we're on our way to solving this. One of these is guaranteed to be 7, so this can't be 7 here. And where is the 1 remaining in column 9? It has to be there. So that's 1, which is low, which must be next to a high, which is next to a low. We have a guaranteed 2 here. This digit is between 2 unique digits on a whisper 5 line, so it's 7, 8, or 9. This has to be 2, 3, or 4. Cannot be 2, it's 3 or 4. So this cannot be 7 anymore, because 7 can only be next to 1 and 2 on a whisper 5 line. We are guaranteed a 5 somewhere on this whisper 5, on this Renban line. Here we have 2 each of low and high digits, because it alternates between low and high. Same with this. This has 2 low and 2 highs. This is a high digit. These are 1 low, 1 high. This is 2 highs and 2 lows. So that means we have all 4 highs accounted for in box 6, which means this is low and a 5. So we're guaranteed a 5 is here, and this is low. That eliminates 5 here, so this must be a high digit. This is 5 and a low, which means this must be equal to 5 plus another digit, which is a high digit. We don't know what that is. This cannot have a 5 here, because that would be the same as these 2 digits. So 5 cannot be here, because we are guaranteed a 5 here. Where is 5 then in box 3? 5 can never be on a whisper 5 line, because if you subtract 5 or more from 5, you get 0 or less. If you add 5 or more to 5, you get 10 or more, neither of which are digits. So 5 has to be one of these 3 in box 3. This is 5 and a low, so it has to be 1, 2, or 3, because it cannot be 4 because of the 4, 6 pair in the box. This has to be then 6, 7, or 8 to add up to 1 through 5. You cannot have a 5 here, because that would force this to be the same as this pair here, but that would obviously eliminate all possibilities for that cell there. So this is 1, 2, 3, 4, up to 7, possibly. We don't know. Okay. 8 has to be on this Whisper 5 line, but that doesn't really tell us very much. Three or four there. What else do we have? Sum of these 3 digits is equal to the sum of those 3. We know there's a 5 guaranteed here. This is a low-high pair, but we don't know which one's which. Low-high pairs here. That's not helpful. These are the same set. Let's do dark and medium. Those are the same sets. Doesn't help us very much. Oh, if this is 6, this has to be 1 and 5 adding up, which would eliminate all possibilities for that cell. So this cannot be 6. Therefore, we have a 2 or 3 with a 5 there. That was interesting. 6 can also not be here, because if this is 6, that would force us to be 1, to be next to it on a Whisper 5 line, and that would again eliminate all possibilities for that cell there. So 6 in this box 3 has to be one of these 2 cells. So this ren band must be either 2 through 6, 3 through 7, 4 through 8, or 5 through 9. That's still a pretty large range. So we have 3 through 9 here, and then we could have potentially 2 here. We do not have a 6 available on the ren band because we already have the 6 there. 2 can't be here because 2 is guaranteed to be one of these 2 digits. What else do we have? These alternate between colors. So we'll make that orange and yellow. We alternate between high and low, but we don't know which one's high or which one's low. This is next to 2 unique digits on a Whisper 5 line, as is this. So these can only be 1, 2, 3, 7, 8, 9. 4 and 6 are not allowed there. What else do we know? 3 eliminates 3 as a possibility here. 8 can't be here because of 8 in the column. Neither can this. The high here cannot be 6. So we have 1, 2, 3, 4, 7, 8, 9. No 1 there, obviously. What else do we have? These 3 digits sum up to the same sum as these 3. That doesn't really help us very much right now. This is 5. Therefore, it's a middle digit. So if this is 7, that means this equals 2, 5, and oh, I guess that's how we interact. What happens if this is 2, 7, and 9? If this is 2, 7, and 9, this must be 8. That's 3, 5. That works. If this is 7, that's 2, 5. Okay. If this is 7, this could be 1, 6, or 3, 4. And that works still. Um, 3 eliminates 3 as a possibility here. So, to add up to 7, it can be 1, 7, sorry, 1, 6, or 3, 4. So 4 can't be here to add up to 8 because that would be 4 and 4. So if this is 3, if the 4 is here, it has to be here and adds up with 3 to add up to 7. 8 could be 1, 7 or 2, 6 here. So we don't really have that much information there. Huh. Where next? Huh. What happens if this is 8? If this is 8, that forces this to be 3, that forces this to be 7. This then becomes a 2, 5 pair. 7 eliminates 7 here, so it's 2, 5 adding up to 7 there. 8 would not be here, 8 would have to be there. And we have to have 3 and 1 be here as possibilities. No 5 or 8 here. These would all have to be high. So this would be 6 or 9. Cannot be 6 here, so that would force this to be 9. So no 3, no 9, no 7. This is 4, 6 as a pair. One of these would be 1, so this can't be 1. That's 6. That would be 6 then. That would be 1. Would force that to be 4 and 6. So far this works fine. This has to be 1 and... oh, this is the problem. We have 7 here, 8 guaranteed here, 9 here. Where's the 9 in this box? Can't be here, can't be here, can't be here anymore. So that fails. So we know this cannot be an 8. Which means we know this is a 9. So this is 9 here, which eliminates 9 in the rest of the box and column. So this is guaranteed to be 9. This cannot be 9 here. There's no 9 here. So this can't be 4, because 4 can only be next to 9 on a Whisper 5 line. And this can't be 9. 6 again cannot be here. Again, what happens if this is 3? That makes this 2 and 5, which forces this to be 7, which means this can't be 7 here. It's 2 and 5, adding up to 7 there. 9 cannot be here, so 9 would have to be there. 8 would have to be here. That's fine. 2 and 5, eliminate 2 and 4, 2 there, so that's 4, which makes that 2. 5 would force this to be 9, that's 7. Ah, and we have a contradiction. So, we know this can't be 3 here because of how that works. So this is 4. That eliminates 4 in the rest of the row and box. 4 eliminates 4 here, so that's 2, which makes this 4. 2 eliminates 2 here, so this becomes a 3-5 pair, which forces this to add up to 8. So this is 8, which is either 1, 7 or 2, 6 adding up to it, because this cannot be 3, 5, because that would eliminate all possibilities for this cell here. 3, 5, eliminate 3, 5 in the rest of the column. We have lows here of 1 and 2, which can both be with 7 and 9, so that is fine. 8 eliminates 8 in the rest of the box. This is 4 and 9. Where is 3 in column 8? Can't be here because of the 3, 5 pair. Can't be here because of in the box. Can't be here because of 3 in the box. So 3 has to be one of these two. This is definitely 6 or 7. So it's guaranteed to be high. We have high, high, high. We don't know what these are. If this is low, it's a 1. Because we can't have 2, 3, or 4 remaining there. If it's high, it can't be 8. You could have a 6 technically. No, you can't because of the 4, 6 pair in the box. Can't be 8, so then this would be 7 or 9 there. If this is 1, that would force this to be 2 here. And 8 would obviously be 7. This would be 7, 8, or 9. 7, 8, or 9. If this is 7 or 9, this has to be a 1, 2 pair. So we have 1 or 2, 1 or 2. And then this could be 7, 8, or 9 here. So those are the possibilities. If this is low, cannot be 2, cannot be 1. It would be 3. If it's low, if it's high, cannot be 8 or 9. It can't be 6. It would be 7. So this is 3 or 7 here. Okay. That's not too helpful. Okay. Anyways. 8 cannot be here. I was hoping that would be a little bit more helpful, but it wasn't at all. 1, 7 or 2, 6 here. That's not too helpful. So this is 1 low and 1 high guaranteed. This is 2 orange and 1 of the set yellow. We know this cannot be 1 and 2 as a red band because that would eliminate all possibilities for this pair here. Could be 2, 3, could be 3, 4, could be 4, 5, 5, 6. No 6, 7 though. Could be 7, 8, could be 8, 9. That's a lot. That's still a wide variety. Interesting. Interesting. We know there's 1 high digit here. Does that help us any? I don't think so. These three sum up to the same sum as these three. That's not helpful either. So if this is low, it has to be 3, which means this can't be 7. So that would be 8 or 9. We do know one of these 4 digits has to have a 5. Not helpful. These digits cannot have 1 and 9, so we have 2, 3, 4, 6, 7, 8 there. But we could have 5 anywhere there. This digit can't be 1, 4, 5, 7, 9, so we have 2, 3, 6, 8. But that's not helpful. This can no longer be 7. If this is 7, that would require 1 and 2 to both be here, which would eliminate all possibilities for these 2 cells here. So no 7 there. This could be 1, 2, 3, or 4, 6, 7, 8, 9. No 3 here because of 3 in the column. Not very helpful. Eight can't be here. 8 can't be here. 8 can't be here. 8 can't be here. So if this is 5 through 9, we know 9 has to be here. 8 has to be here. Therefore, that would force us to be 7 here, which would mean 7 could not be here. 7 would have to be here. So this couldn't be 7. It would be 1 or 2 here. This would have to be 7 there. That is possible. Interesting. 6 cannot be one of these 3 digits here, cannot be here. So 6 is either on the region sum line, or cannot be here, it would be, or it would be there. That's not too helpful. It's kind of rough. I'm wondering if I'm missing a rule here. I'm pretty sure that these were all the rules. But let me double check. Blah, blah, blah. Thick magenta lines are Renban lines. Thick solid guard German whispers. Nope. Those are all the rules. Okay. Well, we know this couldn't add up to 24. It can't be 3 unique digits adding up to this sum. Interestingly enough, where is the 1 in box 2? It's either here or on the region sum line. But it could very well be there. 9 would also could be on the Renban still if it's 5, 6, 7, 8, 9. So this can't ever be 9. If this were 9, it would have to have 8 on the ren band, but there's no possibility for that because 8 can't be here and 8 can't be here. So this cannot ever be 9. 4 cannot be on the whisper 5 line. So 4 is on the ren band. Oh. Okay. That's interesting. So no, 9 could still be on the whisper 5 line here, and then 4 could be on the red band. So that's not helpful. Hmm. Oh boy. Okay. This is kind of tough. 6 cannot be here. If this is 6, that forces this to be 1, but then that would force this to be a 2-7 pair trying to add up to 8, which is impossible. So this cannot be 6. Huh. This adds up to 21 at most. At least it adds up to 9. That's not very restrictive, unfortunately. This can't be 1, 4, 9, or 3, so we have 2, 5, 6, 7, 8 as possibilities there. Um, 5 could be here as long as 5 is there on the Ren band. Remaining digits in row 1. 2, 3, 5, 6, 7, 8. Obviously, no 2 8s in there because of the 2-8 pair in the column. Hmm. Mm-hmm. Actually, we know this can't be 2, 3. We can know it can't be 1, 2 because that would eliminate all possibilities for this. But if this were 2, 3, that would mean this has to be 1, 7, and this can't be low, so it would have to have a 9, and we'd have to have 2 lows here when we already have 3 lows accounted for. So no 1, 2, no 2, 3. Could be 3, 4, 4, 5, 5, 6. No 6, 7, but it could be 7, 8. Obviously, this couldn't be 7 because that would force that to be 8. So this would be 7 and 8. Could be 8, 9 as possibilities. Ugh, not helpful. Hmm. Hmm. No 6 here because of 6 in the column. Could still be 4, 5, so that's fine. Not really that restrictive still. Where is 5 in row 6? Can't be here. Can't be on the whisper 5 lines. Can't be here because this is a 4-6 pair. So 5 does have to be one of these two digits there. Not too helpful. Oh, cannot be 8 and 9. If it tries to be 8 and 9, then this is a low, and these must be two high digits. But 6 again cannot be here. Why was that? Oh yeah, because it would be 6 and then that would force this to be 1, and that would eliminate possibilities for that. So 9 cannot be here. Can we have 8, 7? We could with a 9 there. That would force 2, 6 there, and we could have 2 lows, so that would be fine. So 7, 8 still works. 6, 5 works, 4, 4, 5 works, 3, 4 works. Okay. Hmm. Mm. Hmm. 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 Okay. I guess it comes down to this probably, these 3 digits, because I don't see any other way to attack this, really. So obviously if 5 is here, that we has to have 5 on the region sum line, but that doesn't help any. We have 5 here. I don't know if that helps. Uh, um, this is kind of tough. I don't know if I would consider this easy. There's a lot of possibilities here, it feels like. Um, hmm. Hmm. Okay, what? This is just so There's so many possibilities. It's crazy. What happens if this is 6? If this is 6, then we have 1 there. That makes this 4. That's 6. So this must be 2, 6 as a pair. Okay. So this is 9. This can't be 3. It's 4. So no 4, no 6. 3 and 5 don't form a Ren band correctly. So this would then be 7 and 8. That would force this to be 7. This would have to be low, so it's 2. Which would be high here, so it's 9. And that would fail here. Because the 7, 9 would eliminate all possibilities for that cell there. Okay. So that's a long, convoluted way of saying this can't be 6. Oh, boy. Am I missing something? I don't think so. We just have to trial and error these things. Okay, what happens if this is 7? If this is 7, this is 2, 5. That forces this to be 3. That's 6. So then this is 7. That means this can't... 6 eliminates 6 here, so that's 1, which makes that 6. This has to be 8 then. That forces this to be 9, and that's 7. That seems fine-ish. That means this can't be 9. It's 1, 2, or 3. This 1, 7 eliminates 1, 7 as a pair. It's 2, 6. That eliminates 2 in the rest of the box, so this can't be 6. This is low, so this must be high. No 8 here, no 9 here. This is low, so this can't be 4. It'd be 2 or 3. No 6 here. Cannot be 7, 8. So it would have to be 4 with either 3 or 5. 4 eliminates 4 here, so that's 6 and 4. That would be 1 or 2, 1 or 2. Oh, so that's helpful. So this can't be a 7 here. We know this is 1 or 9 then. Okay. We have 4 being here. We have a 1, 2, 3 triplet here. That leaves us with 5, 6, 7, 8 remaining in row 6. No 5 or 7 there. No 8 there. No 6 here. So 6 is one of those two. So far, this is looking fine. This is 4. That leaves the remaining digits as 1, 2, 7, or 9 in row 5. Obviously, no 7, no 2, no 1 there. No 9. One of these is guaranteed to be 3. This can't be because we have a 1, 2, 3 triplet in here. So this cannot be 7. It's 8, which makes this 6. No 6 here, no 8 here. We know one of these is 3. That eliminates 8 from being here. So 8's one of those two. 2 eliminates 2 here, so that's 1, which makes this 2, which makes that 3, which makes that 1. This all seems fine. Okay, so we know if this is high. We know if this is high, it has to be a 9. So, okay, let's go through the other scenario. What happens if this is 3? If we have 3 there, that means this is 8 or 9. This can't be 3. This is 2. This would be 1. So we have 7, 8, or 9 here, 8 or 9 here. 2 eliminates 2 as a possibility here. 1 eliminates 1 as a possibility there. Does that help? Not particularly. 3 is there, 1 is there, that makes this 6, which makes this 7. It makes that 9. That helps. That means 6 has to be there, and this can't be. This is 2, 5, and therefore this is 7. So this is always 7, no matter what, for all the possibilities. So this is guaranteed to always be 7, which eliminates 7 in the rest of the box. It also eliminates 1, 7 as a possibility here. This is 2 and 6, which eliminates 2 and 6 in the rest of the box here. And row. This is not 7 here. It's 2, 5 as a pair. This cannot be 5. So we have 2, 5 as a pair. That's 7. That eliminates 5 in the rest of the column. So that's 9, which makes this 7, which makes that 5. So this is high. This is 5. We have 5 and a low here. Okay. 7 eliminates 7 here. So that's 6, which means this can't be 6. So we have 3, 7 as a pair there. 6 eliminates 6 here, so that's 1, which makes that 6. Okay, well, there you go. And that forces this to be 9. So all the darks are high, and all the mediums are low. Which means this must be 7, that must be 3. Huh. We just had to try them out, I guess. This has to be 1 as a low. That makes that 2 as a low. This can't be 2 or 9, so that's 8. That eliminates 8 in the rest of the row, so no 8 or 7. This can't be 9 anymore, so the yellows are low, and the oranges are high. So this can't be 4 anymore because of the 9 in the row. This is 7 or 8. This cannot be 2, so this must force this to be 3, which makes this 1. No 1 or 4 here. Can't be 8. 3 cannot be next to 7 on a Whisper 5 line, so this is 8. That eliminates 8 in the rest of the column. One of these obviously is 8. We don't know which. 3 cannot be here, and cannot be on the Whisper 5, on the Renban line. So this can no longer have 9 on the Renban line. It could be 2 through 6 or 3 through 7. So 8 cannot be on the Renban line, which means 8 has to be here. That eliminates 8 in the rest of the row. One of these is force because it's 3 or 4 or 4 or 5 there. That means this can't be 4, it's 6, which makes this 4 there. That leaves 5, 6, and 7 remaining in the rest of the row 6. No 5 or 7 here because of 5 or 7 in the column, so that's 6, which eliminates 6 here and 6 there. So we have 5 and 7 there. 8 is here. This is high, low. We know one of these is low. This can be 3, 5, 7, or 9. No 7 here because of 7 in the row. So where is 7 in box 5? It must be one of these 2 digits here, which eliminates 7 in the rest of the column, so there's no 7 there. We know there's a 5 guaranteed on this Renban line, and so it's one of these 3. 3 eliminates 3 here. Bill hopes eliminates 6 there, so this can't be 6. No 3 remaining there. That was kind of convoluted. Anyways. So 7 has to be one of these 2, which eliminates 7 in the the 7-9 pair eliminates 7-9 in the rest of the column, so this can't be 7. It's 5, which makes that 7. 5 eliminates 5 here. So where's the 5 in box 2 on this Renban? It has to be here, which eliminates 5 here. So that's 4, which makes this 5. 4 then can't be here. Where is 4 on this Renban, which we have to have? Because it's 2 through 6 or 3 through 7, both of which include a 4. It has to be here. So this is 4 and is low. This is 5 and 2 or 5 and 7. We're not sure which. Therefore, this can't be 5. This is 3, 4 as a pair. And 4 eliminates 4 here, so that's 3, which makes that 4. These are both lows. This can't be 3 or 5. It has to be 9, which makes that a 7, which eliminates 7 there, so it's 9 and 7 there. This is a high. 9 eliminates 9 here. So the high here cannot be 6, 8, or 9. It's guaranteed to be 7. So this cannot be 7. This is 2, 5 as a pair here to form the rem band 2 through 6. That eliminates 2 in the rest of the column, so this can't be 2. That's 6, which makes that 2. So no low, no high here. 2 eliminates 2 here. That's a 1, and that leaves us with a 6 in column 6. Remaining digit in column 5 is a 9. 1 eliminates 1 here, so that's 2. And we are left with 1 or 3 here because we have all high digits left in row 3, or all high digits accounted for in row 3. That means the rest of row 3 are low or 5 digits. Or low or 5, not high. So this can't be 5 because of 5 in the column. This is guaranteed low also. This is low. 3 cannot be next to 7 on a whisper 5 line. So this must be 7 and 1 there, which makes that 3. This is not red. This is not blue. 3 eliminates 3 here, so not 3 there. This can't be 5 then. So this is 5 and 3 there. 3, 6, 9 adds up to 18. Okay. 2 to add up to 18 would have to be with 2, 7, 9, and 9 is not available here. So this cannot be 2 as the lowest digit. It has to be 4 or 5 as the lowest digit. 4 could be 4, 6, 8, but that would eliminate all possibilities here. It could be 4, 5, 8, too. Remaining, okay, so this is guaranteed to be low or 5. So this is 4 or 5 here. Again, we can't have 2 here. That would force 7 and 9 to be there to add up to 18. And we can't have that because of 9 in the column. So this is 4 or 5. This can't be 5. The 7 eliminates 7 here. Because we can't have 4 and 5 add up to 18 without a 9. So this is guaranteed to be 4 or 5 then. This can't be 5 then, and it can't be 7, so that forces this to be 6, which makes that 4. That eliminates 4 there, so it's 3 and 6. This can no longer be 4, it's 5. So it must be 5, 6, and 7, adding up to 18. 5 eliminates 5 here, so this is 2, which makes this 5. No low, no 5 here. No low, no 5 here. 5, 6, 7 eliminates 5, 6, 7 here, so this must be 3, which makes this 2. And these are low digits, which must be a 1, 4 pair. 2 eliminates 2 here, so that's 5 and 2 there. We have 8 and 9 remaining here. 8 can't be here because of 8 in the column, so that's 9 and 8. Remaining digits of column 3 are 2 and 8. This can't be 2 because of 2 in the row, so that's 8 and 2. Remaining digits of row 5 are 1 and 9. 9 can't be here because of 9 in the column, so that's 1, which makes that 9. 1 eliminates 1 here, so it's 4 and 1. That leaves this as a 4 and this as a 5. I would not classify this as easy. The logic isn't... it's still... yeah, I don't know. You have to go through a lot to try to figure this out. You have to basically just trial and error it. And that takes a lot of steps to do that. So, yeah, I would not classify this as easy. I would say this is challenging level. Either way, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.